Hello everyone. Today we are going to discuss the topic, the paper October-November 2024. This one is paper 43 of October-November 2024. Okay, now let's start the first question. That an athlete has mass mkg. The athlete runs along a horizontal road against a constant resistance force of magnitude 24 Newton. The total work done by the athlete in increasing his speed was 5 meters per second to 6 meters per second. While running a distance to 50 meters is this. So the total work done is this. Find the value of m. Now what we have to do, we know that the total work done is 15 for 1, and now we have to subtract what? We have to subtract the distance and the resistance force. So work done against the resistance force will be equals to 24 multiplied by 50, and then this should be equals to half mv square. We know that this will be the change in kinetic energy, so this should be half mv square. Mv square means velocity is 6 first, mv square minus half mv square. Now if we simplify it further, we need to just rearrange it and we will get the final answer. So the final answer will be So this will be, we can simplify it over here, that then this will be 1541 minus 24 into 50. So this will be equals to 341. So 341 is equals to, we can take m as common. So this will be 1 by 2 into 36 minus 1 by 2 into 25. Now if we simplify it, this will be, so this will be basically 18 minus 1 by 2 into 25. So this will be 11 by 2. 11 by 2. So 341 is equals to 11 by 2 m. And if we rearrange it, 341 multiplied by 2 divided by 11 will be the final answer. So we can use it like this will be, we can use it over here, 341 multiplied by 2 whole divided by 11. So the final answer will be 62. So the mass will be 62 kg. Okay, now one thing is that we need to convert it. This will be m is equals to 62. 62 will be the final answer. Let's move to the next question, question number 2. Now question number 2 is the coplanar forces of magnitude 16 Newton, 12 Newton, 24 Newton, 8 Newton act at a point in the direction shown in the diagram. Find the magnitude and the direction of the single additional force acting at the same point which will produce equilibrium. So now we know that if it is in equilibrium, we need to find out the horizontal components first. So horizontal component should be equals to, sum of horizontal components will be equals to, let's see the horizontal component. 24 Newton force is going towards the right side. So 24 plus, now this will be the horizontal component of 12 Newton will be, now as we can see that this one is moving towards the right side. So 12 sine of 30 degrees. Sine because this side is perpendicular for sine 30. Okay, now for this one, for 8 Newton, again it is going towards the right side. The horizontal component is going towards the right side. So 8 into cos of 30. Then this one is going left side. So minus 16 cos of 30. So this should be equals to 0 because we have to make it in equilibrium. So let's find out the values over here. So 24 plus 12 sine of 30 plus 8 cos of 30 minus 16 cos of 30. So the answer will be 10.9. But one thing is that we need to check that right now my calculator is in reading mode. You have to be very careful about this. You need to convert it into degree mode. Now if you find out the values, your answer will be 30 minus 4 square root of 3. 30 minus 4 square root of 3. Okay. I hope that this thing is clear to all of you. So horizontal component is 30 minus 4 square root of 3. Let me check it that whether it is a positive number or a negative number, or in other words 23.07. Yes, 23.07. Okay, now let's find out the horizontal components, the vertical components. Now for vertical components, this will be summation of Ry is equals to, now the vertical component of 24 Newton will be 0. So we don't need, because it is a pure horizontal force. So we have to see the vertical component of 12 Newton. Now for 12 Newton, the vertical component will be as it is going upward. So this should be 12 cos of 30, cos, because this side is the base side of this triangle. Now for 8 Newton, we need to see that this one is going downward. That is why we will take it as 8 sine of 30, because this side is the perpendicular side. Now similarly for 16 Newton, we have to see minus as it is going downward. So this should be 16 sine of 30. Now we can easily find out the values over here, and we can see that 12 cos of 30 minus 8 sine of 30 minus 16 sine of 30, this will be equals to minus 12 plus 6 square root of 3, minus 12 plus 6 square root of 3. This one is the horizontal, this one is the vertical component. Now let me check that this one is going positive or in a negative way. So if we convert it into decimal, so as we can see, this one is a negative number. So we can clearly identify that our force, our resultant force, to keep it in equilibrium, this one should be going towards the right side, and towards the right side will be 30 minus 4 square root of 3, and then it should go downward, and it should go downward, and this component should be 6 square root of 3 minus 12, and hence we can say that this should be the direction. This should be the direction of the resultant force. Now we need to find out the angle theta. This should be the direction first of all. Now we need to find out the angle theta as well as the magnitude, because we need to find out the magnitude and the direction of the resultant force. So we know that the magnitude of the resultant force will be equals to 30 minus 4 square root of 3 whole square, because the formula is R is equals to summation of Rx whole square plus summation of Ry whole square. Now if we simplify it, this will be 6 square root of 3 minus 12 whole square. Now if we calculate this one, this should be, by the way, this one we have the answer for the vertical component, so we can use it this one directly. So plus bracket 30 minus 4 square root of 3 square. So now we need to take the square root. This will be equals to 23.1 Newton. So R will be equals to 23.1 Newton. This should be the final answer for the resultant components. Now let's find out the angle also. So the angle will be, theta should be equals to, because tan theta will be equals to summation of Ry by summation of Rx. So theta will be equals to tan inverse of summation of Ry was 6 square root of 3 minus 12 divided by 30 minus 4 square root of 3. So this will be equal, theta will be equals to, now we need to calculate it like this, that tan inverse of shift tan inverse of fraction and 6 square root of 3 minus 12 divided by 30 minus 30 minus 4 square root of 3, and if we see the final answer, this will be equals to minus 3.99. So minus 3.99, or we can say angle will be 3.99 minus 3.99, or we can say that the angle will be theta will be 3.99 below the x-axis, below the x-axis, or we can say positive x-axis. So this should be the final answer. I hope that the concept is clear. Let's move to question number 3. A car of mass 1600 kg travels up a slope incline at an angle of this. There is a constant resistance of magnitude acting upon a car. It is given that the car travels at a constant speed of 32 meters per second and constant resistance. Resistance is constant, 240 newtons. So what we can see, we need to find the power of the engine of the car. So power of the engine of the car. Now we know that the power of the engine of the car will be equals to P is equals to FV. Now here we can see the driving force. So P is equals to, we need to find out the driving force first because we know the velocity here. So how to find the driving force? So driving force will be equals to, driving force should be equals to, we have two forces over here. As you can see, this one is an inclined shape and the angle is given to us. So the driving force should be equal to, we can see that the weight is going downward. So this should be, we have one component is of the weight and the other component, so we need to see the horizontal forces and vertical forces. This one is going backward side. So driving force should be equals to the component of the weight. So this should be W sine theta plus the resistive force because the resistive force is going backward and this component is also going backward, and this driving force should be going in this direction. So we can make we can create a scenario over here and we can easily find out the driving force. So weight should be equals to mg. So 1600 into 10 into sine theta. Now we know that the angle is sine inverse of 0.08. So sine theta will be equals to 0.08. So we can directly use the value of 0.08 over here plus 240 newtons. So if we simplify it, we will have the driving force. So driving force will be, let's find out the driving force first. So 1600 multiply by 10 multiply by 0.08 plus 240. This will be 1520. So the driving force is 1520. Now what we have to do is we need to find out, we just need to put it over here. 1520 into 32 will be the power of the engine. So power of the engine will be equals to 1520 multiplied by 32. This will be equals to 48640. This will be the final answer. I hope that the concept is clear. Let's move to the B part. Find the acceleration of the car when the speed is 24 and the engine is working at 95% of the power found in A. Okay, it means that now the power of the engine is previously it was 48640. So 48640 640 multiplied by 95% means 0.95. So this will be equals to multiply by 0.95, sorry, 0.95. So this will be equals to 46208. Now the new power is 4620. Now what we have to do, as we have discussed earlier, that if we create a scenario over here, we can directly say this one is the resistive force, this one is the driving force, and the power has been changed now. Now for power, we need to find out the driving force. So the driving force should be, because we know that the velocity is 24 Newton, so we can use it as, we can find out the driving force. So drive P, we know that, now we know that P is equals to Fv. So if we rearrange it, so driving force will be equals to P by V. Now P is 46208 divided by 24. So if we divide it by 24, now the driving force is now 5776 divided by 3. Now we can again use the calculation over here, that this one will be the resistive force, this one will be the driving force, this one will be the weight acting downward. So if we resolve it into its component, so Fr will be equals to driving force minus frictional force, driving force minus, we can see the resistive force, which is fixed. In this case, that the constant resistance of magnitude 240 newtons, we cannot ignore it, minus the component of the weight W sine theta. Now if we just put the values over here, so then driving force is 5776 divided by 3 minus 240 minus 1600 into 10 sine theta is 0.08. Now this should be equals to, if we simplify it, this will be equals to this should be equals to acceleration of the car. Okay, this will be equals to, let's find it out over here, minus 24 minus 1600 into 10 into 0.08. now this will be equals to 1864 by 3. Now there is a slight change, that the resistive force is 240, so we need to change it over here, that this should be 240. Okay, now if we calculate it, this will be 1216 over 3. So you can see that if we simplify it, we will get the final answer. Now this will be, let me write it over here, 1216 by 3. Now we have to find out the acceleration. So we know that F is equals to ma, we know the mass, we know the resistive force. So this will be 1216 by 3 is equals to m is 1600 into a. So a will be equals to 1216 by 3 into 1600. Now if we calculate it, if we divide it by 1600, we will get the final answer, and the final answer will be 0.253. So acceleration for this case will be a is equals to 0.253 meters per second square. I hope that the concept is clear. Let's move to the next question. Question number 4. Two particles A and B of masses 3 kg and 6 kg respectively lie on a smooth horizontal plane. Now 3 kg and 6 kg lie on a smooth horizontal plane. Initially B is at rest and A is moving towards B with the speed of. So we can see that we have two particles. Let's make a scenario over here. That we have two particles A and B of masses 3 kg and 6 kg. So 3 kg and 6 kg. Okay, so this one is particle A, this one is particle B. Now they are saying that lie on a initially B is at rest and A is moving towards B. A is moving towards B. This one is A, so A is moving towards B. And B is at rest and A is moving towards B with speed of 8 meters per second. So the speed is 8 meters per second. After A and B collide, A moves with the speed of 2 meters per second. So A is now moving with the speed of 2 meters per second. After collision, A is moving now with the speed of 2 meters per second. Find the greater of the two possible total loss of kinetic energy due to the collision. So first of all, we know that law of conservation of momentum will be m1 u1 plus m2 u2 is equals to m1 v1 plus total collision before total momentum before collision is equals to total momentum after collision. So if we simplify it, we know that the mass is 3 for first particle A and the acceleration, the velocity is 8 plus m2 is 6 into 0. Now m1 is 3 and initial velocity was 2 plus m2 was 6 and we don't know the second velocity, the velocity of the particle B. Okay, let me write over B over here. So if we simplify it, this will be 24 minus 6 is equals to 6 VB, and hence we can say that VB will be equals to the velocity after the collision of particle B will be equals to 18 by 6, which means VB will be equals to 3 meters per second after the collision. I hope that this thing is clear, but we have to find out the change in kinetic energy due to collision. So how we can find it out? So we can find it out using we know that kinetic energy is equals to half mv square. So half mv square, mass is 3 mv square for the first one, minus we need to subtract it with after the collision. So this should be 1 by 2 mv square. This one is after collision, mv square plus half 6 into 3 square. Now if we simplify it, this will be, let me simplify it over here, 1 by 2 3 into 64 minus this will be 1 by 2. Now this will be 1 by 2 into 3 into 4 plus 1 by, basically we can cancel out over here 3. So this will be 3 into 9. So finally we can have 2 ones are 2 32s are. So this will be 32 into 3 96 minus 2 ones are 2 twos are 6 plus 27, and if we simplify it, so we can say that this will be 96 minus 33. 96 minus 33 will be 63 joules. So we can say the greater of the total loss of kinetic energy, will be greater loss of kinetic energy will be after collision will be equals to 63 joules. That is it for today. Tomorrow we will discuss the remaining questions of this paper. Today we have discussed question number 1 to question number 4 of October-November 2024 paper 4-3. I hope that the concept is clear, but still if you have any question, you can see the link in the description. You can see the WhatsApp number over there, and you can just click the link, and you can join my WhatsApp link, and keep watching the next the remaining questions. We'll upload the remaining question in a couple of days. Thank you.